Okay, we are starting chapter 8, and the first section in chapter 8 is called similarity and right triangles. So we've talked about chapter 7 already, where we talked about similar triangles. And now we're going to talk, and then we went to chapter 5 and we talked about right triangles. So now we're pushing those two chapters together. And by the end of the video, you should know how to use geometric mean to find segment lengths in right triangles. And so we're learning an alternative to the Pythagorean theorem method, and we're going to apply similarity relationships in right triangles to solve problems. But before we learn how to do that, I want you to check and see if you know how to answer these 5 questions. So pause the video, make sure you know how to do these five questions. Okay, so here are the answers to these 5 questions. In number 1, write a similarity statement, which is just like a congruency statement. So this is saying that angle A is congruent to angle E by the third angles theorem. Angle D is congruent to angle D. Sorry, I don't know what this is. And angle B is congruent to angle C, which it says. And to simplify a radical, all we have to do is the factor tree. So really quickly, to simplify 27, that breaks it down into 9 and 3. And then 9 goes into 3 and 3. Here's a pair. They go out. Loner stays in. And so 3 radical 3 is the simplified form here. And to solve number 4, you cross multiply and solve. And to do this one, you divide by 2 and then do the square root. And remember, because we have an exponent of 2, we should have 2 answers, which is why it's positive 5 and negative 5. Okay, so now we're ready to complete the lesson. We have all of our tools. The first thing we're going to do is talk about geometric mean. Geometric mean is basically the same thing as a proportion, where the variables x and x are across from each other. So let's say I wanted to find the geometric mean of 4 and 6. The geometric mean has the word mean in it. And what you guys are used to doing is the algebraic mean. In pre-algebra and algebra, you guys learned, and I don't even know how young you were when you started talking about mean and average, but the algebraic mean is where you add up the two numbers. Let's say it's x1 and x2, and you divide by the number of numbers. Let's say there's another one, x3, so you would divide by 3, and that's algebraic mean. Geometric mean is different. Geometric mean is the positive square root of the product. So we're only talking about 2 numbers, A and B. And it's only positive. We don't want negatives, because usually I said 2 means we have 2 numbers, 2 answers, right? We only want the positive ones. So if I wanted to find what's the geometric mean of these 2 numbers, you could set it up like a proportion every single time. 4 over x equals x over 6. You can set it up like this. You could set it up as 6 over x equals x over 4. You could set it up as x over 4 equals 6 over x. The only thing that matters is that the x's are across from each other. And that's because when you cross multiply, you're going to get x squared equals 24. And then you square root and you take the positive answer. So 6 and 4, 2 and 3, 2 and 2. You're going to get that the answer is 2 radical 6. So that's the geometric mean of 4 and 6. And a shortcut to do that is just to say that x equals the square root of the first number times the second number. Because what is 4 times 6? Well, it's 24. And all we did was we square rooted it. So this is the shortcut. If you cannot remember this, just fall back to the proportions and solve. So there's lots of examples. And I'll show you why we're doing geometric mean. It goes along with similarity and right triangles. So solve this one, 4 and 25. Again, if you don't remember, you could always do proportions. The shortcut, though, is to say that x equals the square root of whatever 4 times 25 is. And that's 4 times 25 is 100. So x would equal 10. The geometric mean is 10. Okay, moving on, 5 and 30. Pause this one. Try to see if you can do this one on your own. So we know that geometric mean is the square root of these 2 multiplied together. So 5 times 30 is 150. And then you split it up. So let's see, we can do 15 and 10, 5 and 2, 5 and 3. Here's a pair, they go out together. 5 radical 6, because 2 and 3 are loners. So if you got 5 radical 6, you are good to go. You know what geometric mean is. If you don't, if you didn't get that one correctly, try this one, 2 and 8, and try 10 and 30. Okay, there's lots of examples for this one. I'll do 10 and 30. So x equals the square root of 10 times 30. And so that's the square root of 300. I could break that down into 103. And I know that the square root of 100 is 10 and 10. So our answer would be 10 radical 3. Okay, so geometric mean. That's just, you know, pretty much you just need to know the shortcut, or you can put it into a proportion. Moving on, again, if you're not sure, here's another one just to try. Okay, the reason why I want you guys to know how to do geometric mean is because we're going to now apply it with triangles and right triangles and similarity. So if I give you a right triangle, triangle ABC, and I put a perpendicular line through that triangle. It's not a perpendicular bisector. CD is just perpendicular. It's not a bisector. BD is not congruent to DA necessarily, okay? But what happens is you're going to split this original right triangle, this big right triangle, into 3 similar triangles. You have the big triangle, you have this small triangle, and you have this other triangle. These are all 3 similar triangles, and the reason why is because of angle similarity, I'm pretty sure. Because they will all have right angles, excuse me. And let's see, this one shares this angle with this big triangle, and this one shares this angle with this triangle. And why is the other one similar? I think the other one is similar because of, I can't remember, but we'll figure it out in just a second. Sorry, I can't remember it off the top of my head. But trust me when I say that all of these 3 triangles are going to be similar to each other. And the first thing they're going to have you do in your homework tonight, besides geometric mean, is to compare the right triangles, the similar right triangles. So they're going to give you a picture like this. And if you need to, you are more than welcome to redraw the triangles. You know me, I can't see things, I have to redraw it for myself. So this is the original big triangle that they give you, the big right triangle, triangle UWV, UWV. They just tilted it just a little bit. And then we have this bigger triangle, WZU. So I'll call this one number 2. I don't know why I chose number 2, random. Okay, so they both have angle U in common, and angle Z is a right angle, as well as W. So these are 2 triangles that are similar by angle. And then this one, oh, sorry, yeah, and then this one is, let's see, this one is a smaller triangle, so I'll call this one number 1. And there's WZV, and this one has angle Z is the right angle, and angle V is similar to this one. So, so these 2 triangles are similar by angle. Now, if we talk about let's say I gave these actual numbers. So let's say this is 90 degrees and this is 10 degrees. By triangle sum theorem, what does angle V have to be? Well, it has to be 80 degrees because all 70 degrees. That's because all 3 angles have to add up to be, wait, I'm sorry, I don't know what I'm doing right now. All 3 angles have to add up to be 180 degrees. So if this one's 90, I was right the first time. This one has to be 80. Okay, so we said that these 2 angles, angle U, are the same thing. So that means this one also has to be 10 degrees as well. So that means angle W would also have to be 80 degrees by the third angles theorem. And then if you look over here, we knew that angle V is the same thing. So this one would have to be 80 degrees as well, and then angle W would have to be 10 degrees. Now some of you guys might be thinking, hold up, Miss Broyles, you made another mistake, because in this triangle it's 80 degrees and in this triangle it's 10 degrees. What are you trying to say, Miss Broyles? Well, let's look at the triangle angle 2. W in this triangle is talking about this part. So this part is 80 degrees. And if you look at triangle angle 1, that's this part of W is 10 degrees. And if you add the 80 and 10 up, do you get 90 degrees? Yes, you do. So these 3 triangles are all similar by angle. Okay, the first thing you need to do is just write a similarity statement comparing these 3 triangles. So if you need to, redraw the triangles, and then all you have to do is say triangle UVW is similar to triangle UWZ is similar to triangle WVZ. So I went from this angle to this angle to this angle in all three triangles. If you can see that in this picture, then you are awesome and you do not have to redraw the triangles. But some of us will have to. So let's try that again for this one, and then I'm going to pause the video and I will give you the answers on the second video.